So in the last episode, we got the front diff all finished up. We got the ARB Air Locker installed and the 488 gears, and everything's back reinstalled into the axle housing, got the drive shaft back on, and now all of this is done. But now we have to finish up the rear because, as you can see, we do not have a differential in there. So we're gonna get this 9.5-inch Land Cruiser diff built today. We have Nitro 488 gears, of course, to match the front, and an ARB Air Locker, of course, to match the front as well. So let's get into it. So I'm about to start this video. I'm standing in this corner back here, and I was just gonna do a walkthrough of all the stuff that we're about to do. And look what I find just waiting behind me in that corner. Our little friend, little Black Widow right here, just waiting for me. I don't see a lot of those on our property here, but they've been hanging out in the shop in these corners, and this is a little tiny one, but still kind of startling to just be standing basically right here. You turn around and this guy was facing towards the camera this way, like, hey, what are you doing in my space? So I'm gonna dispatch this fellow right here, and then we'll just get to the video. So here are the new shiny gears from Nitro Gear and Axle. This is a 488 set, as I already mentioned. If you wanted to be sure, you could check the stamping on the side of it right here, which you can probably just barely see. It says TLC 488. That means Toyota Land Cruiser with the gear ratio of 488. Another thing you could do is count all the teeth on the ring, count all the teeth on the pinion, and divide them, and you'll get the gear ratio. Now, if this is your first time doing something like this, we do have the whole install video from the front diff is gonna be way more descriptive. I'll put that in the description below, but just to quickly go over this is what you're gonna get in a ring and gear set. Unless you buy the setup kit, that's all you're gonna get. So the setup kit is over here, and you can see this comes with basically everything else we need. All the bearings for the pinion, the carrier bearings, the pinion nut. It's gonna come with all that stuff that you would need to finish up this install. These are usually coated in something from the manufacturing process that I assume is there to probably prevent rust during storage and shipping. So the first thing that I like to do is get all of this gunk off the ring and pinion, and then get the new ring installed on the carrier. Those are tight. All right, now these should just come right off, and they do. I didn't want to use an impact on it because I'm worried about shaving any material off of these nuts, and I just feel better about taking them off this way. So anyway, when these things come off, there's a shoulder, little shoulder right there, and these go in a certain way. We need to be aware of that. You can kind of see here where the shoulder will go. Looks like it points towards the teeth of the ring gear. So when we take these out, we just need to be aware that you can't just toss these things in any way you want. They go in a certain way. And we'll toss these into the ultrasonic cleaner as well, just to get them all nice and free of any oil or grease before we put Loctite on them in the new diff. So I know somebody's gonna be watching this video thinking, dude, why the hell did you just reuse 30-year-old ring gear bolts in your brand new setup? And here's the reasoning. The Nitro Gear setup kit, all the other setup kits, they don't come with ring gear bolts because they expect you to reuse the old ones. You could source new ones if you wanted to. I didn't really want to do it, and I talked to Ken Francisco as well, also known as Zuck or Zook. I'm sorry, Ken, I always mess up your name. If I was going to say it, I'd call it Zuck, but it's probably Zook. This guy is like the god of Toyota installs. He's known across Yoda Tech and I Hate Mud and all these different Toyota forums for being like the go-to guy to get your Toyota gears installed. I messaged him. He said, reuse them. They're fine. He does the same thing. If Ken does it, I'm going to do it. And that's the reasoning. So I guess time will tell if anything happens, but I'm going to guess we're going to be fine for years to come. I mean, I come from a world where back in the 240SX days, before they were the most overpriced vehicle in the world next to a first-gen Toyota 4Runner, We used to tear apart the diffs, weld them together for drifting. We welded the spider gears together with a Harbor Freight flux core welder before Harbor Freight sold any sort of decent tool. These welders were junk. And I mean, we didn't know what we were doing. These were the shittiest welds in the world, excuse my language. And guess what? They never broke. And there was spatter in between the ring gear and the pinion. That thing was basically just chomping up metal as we were drifting these cars. And that's because we didn't actually touch the differential. So everything was still set up from the factory, the backlash, the pinion depth, all that stuff wasn't messed with. And because it was in those factory clearances and everything was so tightly clearanced, I know I'm saying clearance a lot, but that's a big deal of setting up differentials. They're pretty forgiving when they're set up correctly. So I think we're going to be just fine reusing the ring gear bolts. I don't need to justify it, but I guess that I am, just because I know someone's going to be like, dude, why'd you do that? Anyway, as we're waiting for that ultrasonic to clean all of our parts, I wanted to give you guys an update on the backyard situation. So if you watched the last video, we just finished leveling out all of this area in front of the shop and laying down the grass seed. And now, today, all the grass came in. So all the hard work paid off. The grass looks really good. Got a couple of weeds in it throughout it, but you know, we planted it basically as late in the season as we possibly could. Basically mid-October. Grass isn't growing anymore, it's getting too cold. But it looks really good. I think it came out awesome. So if you guys were invested at all in this update of the shop, that's how it's looking now. All right, getting back to the gear install. Now it's time to put the ring gear onto the new ARB locker. These are normally pretty flat, but I still like to hit them quickly with a file just in case there are any edges, ridges, or other imperfections that I want to get out of there. And on a nice sunny day, normally I'd put the ring gear out in the sun for a while to expand it just a little bit to help it slide over the carrier. But with this colder weather, it's just not gonna happen. So I picked up this hot plate, which worked really well, surprisingly, and a lot cheaper than an induction heater. And it allowed me to drop the ring gear right on with no issue. And then it was time to clamp this thing down in the press and tighten all the ring gear bolts to 81 foot-pound. Well, we are moving right along. The ring gear is installed on the ARB carrier here, the locker, and now we're gonna move on to the carrier bearings. So that's gonna be these two that are the same. The ones that are different are the pinion bearings. You got the big pinion bearing, small pinion bearing. So we have this guy right here. And by the way, I like to keep the races with the bearings. I'm not really sure it matters, but I like to keep them with it. So I'll make some sort of paint marking or something like that. Let me close this door real quick. The neighbor's mowing and it's loud. Anyway, there's two ways to get these things installed. You can either heat them up on either a bearing heater or a hot plate like this, or you can just press them on. I'm gonna try to use my hot plate because I just got it, and normally I press these on and I kind of want to see how it goes. But as you can see, these do not just fall into place. Like, yeah, it's not just gonna go on there. And it needs to go all the way down to here. So we're gonna clean up all the sticky manufacturing residue off this bearing and off the collar, press the carrier bearings on, and then we're ready. Essentially at that point, the whole assembly with the carrier and the locker and the bearings is done and it can be put into the third member housing. But we still have to finish up the pinion side and then we can start checking a gear pattern. Well, I'm not gonna lie to you guys, the other side went on really, really easy. And now I switched to this side, and just off camera, I tried to put it on there and it just went all cockeyed, and then it cooled down and basically was, you know, stuck because the clearance is tightened up, and then I had to take it all back off. So not working quite as easy in my opinion as a press. I'm also a bit scared to get it too hot because I don't want to compromise the integrity of the bearing, and I have TIG gloves on, so they're not really heat protected, but I keep checking the temperature of this thing. We're wanting it to get like 240-ish degrees. I feel like it's there. It just needs to get like 150 degrees hotter than this sleeve. So I'm gonna try to drop it on, and if it doesn't go, we'll just press it, I guess. Hammer this thing down. At least it's square on the collar. We'll just press it the rest of the way on. The carrier's done at this point, but we have a new issue. If you take a look at these bearing races right here, this one's clearly larger than the factory one. So what I'm gonna do is just inspect this bore and see if it even looks like it can work. So take the depth of this bore with my caliper here, and it's about right here. So if we look, focus, if we look at this old race, of course it's the exact size it should be, but the new race is too big. So I don't think this is gonna work with this new bearing and race. So I did some research off camera, and yeah, I ordered the factory bearing and factory race for the outer pinion bearing because I'm not gonna use this thing. It's not just the race that's different, the whole bearing is different. Let me show you what I found out. So this is the factory bearing here and the factory race. As you can tell, both the race and the bearing are completely different. The taper angle is different and the thickness is different. So you see this factory race right here, it's about 1/8 of an inch shorter than the aftermarket one. And another big issue here, if I could not drop it, is the shoulder. So the aftermarket one's really thin, gonna be a lot harder to take that out and service it in the future as compared to the factory one. So I just don't feel comfortable using something that's so visibly different. Might not make a difference at all, but not in my differential. We're not putting that in there. So we're gonna be, well, I already did order a factory replacement for this. But what I'm gonna do in the meantime, and by the way, the inner pinion bearing is just fine, but what I'm gonna do in the meantime is toss in the old outer pinion bearing to at least be able to set my pinion depth and move on with the install. And then once the new one comes, we'll swap it out. And one more reason not to use this new bearing and race is, if you remember just a couple seconds ago when I checked the depth of this bore with my caliper, which isn't the most accurate way to do it, but it works. And what we found was that the factory race here on the left was the exact depth of that bore, of course, and the aftermarket one right here on the right was not the exact depth. In fact, it's a little bit taller, about 1/8 of an inch. As you can see, this line in here, this machined groove, is the depth of the bore for that race. And we have here, I put a flashlight down there so you can see it's actually illuminated inside there, the port. And if we were to put the taller one in there, it's gonna at least somewhat restrict this port, which to me looks like a feed for this bearing to get extra oil to it. So if we're somewhat impeding the flow of oil to that bearing, and we have a different bearing in there, and the taper is different, it's just a bunch of things that sit wrong with me. Well, now we can move on to the pinion, and what we need to do is shim the pinion correctly. So as I said previously, we take the shim off of the factory pinion here, and I absolutely destroyed the factory bearing in the process. So, I mean, I didn't care, so I wasn't really careful, but when you're pulling bearings off, always pull from the actual inside body, I don't know what to call it, the thick inside metal, and never the cage itself. Of course, doesn't matter here because it's the old bearing and it doesn't matter. So this factory shim is 47 thousandths, and I typically do just use the factory shim, but I read online that 57 thousandths is a good place to start with Nitro Gear sets. So I'm gonna try that, and if it's too deep, then we'll adjust it. If it's too shallow, we'll adjust it. We're not gonna get it right the first time anyway, unless we're very, very lucky. So we're getting 57 thousandths out of these two shims, and I'm using the hot plate again to heat up the pinion bearing and attempting to drop it right on the pinion. And I'll be honest, I'm shocked that this worked because I normally use a press for this, but I just wanted to give it a shot. Now I'm installing the pinion into the diff without a crushed sleeve or solid spacer, just the bearings. And the point is to set the preload manually for testing the gear pattern. everything that we're doing in this step is reflective of the final setup. The backlash is in spec, the pinion preload is in spec, and we tossed in some carrier bearing preload to just give us the best representation of what the gear pattern will be at final assembly. And unfortunately, this pattern is just a tad too deep, so time to tear everything back apart and try again. Better luck next time. And another issue that I found here was that the ring gear was very, very close to the housing with only 3 thousandths of clearance. I'm definitely gonna have to clearance this part out. All right, try number 2. That's just the name of the game with these things. They don't typically go the first time around, so hopefully now we took 5 thousandths out of it and the pattern's better. Let's see what we get. Well, it looks like we nailed it on the second try. You can see here it's slightly deep, but that's okay. If we were to adjust this anymore, we'd have to pull maybe 2-3 thousandths out of it. We're just gonna end up back at the factory shim at that point, and then it's gonna be slightly shallow. Or perhaps it might be right in the middle, but I'm okay with this pattern right here. Rather have it slightly deep than slightly shallow. So here's the coast. You can see it's kind of favoring toe, and that's okay. Those kind of things are harder to change and harder to adjust. We don't have direct control over that as much as we do actually changing this gear pattern. And here's the coast. So this is looking pretty good. And also we have way more clearance in this corner now. I need to get better lights, but as you can see, we have way more clearance for those teeth on the ring gear. Nothing's gonna hit. So now we're just gonna wait for that bearing to show up so we can tear all this thing back apart, which we have to anyway because we have to install the solid pinion spacer. But in the meantime, we can drill the hole for the bulkhead. Well, it's been a week since the last clip in this video, and that's because we've been waiting for this bearing to show up. But it's finally here. We can get it installed. It matches the OEM bearing. So let me just go over it one more time, why we had to use this one instead of the one that came with that kit. If we look at the Nitro race right here compared to a factory race, the Nitro race is much thicker, as I already showed in the video. Not to mention the back of them are different. This one has a wider ledge. This one's a more narrow ledge. That has to do with the taper of this bearing compared to stock. And that's the biggest issue that I found, is if you compare these two, this is the Nitro bearing here on the left, it's OEM on the right. The difference in the taper of that bearing, they're just not the same bearing. And they do have very similar part numbers, but they're not the same. So Nitro one, 30306JR, OEM bearing, 30306DJR. So if you want to replace your outer pinion bearing, you have a similar issue like this is the part number from Toyota. Now it's time to set up the solid spacer and get the pinion preload dialed in. First, the new race goes in, and then we have to start checking the preload with the solid spacer. When I measured this Nitro spacer, it was very close to the length of the old crush sleeve, which I thought was really weird. So my first instinct was to try without any shim, and of course that turned out to be way too tight. There was way too much preload. So once again, this has to all be torn back apart. At least now we're just popping out a pinion, and then we have to try another shim. Alright, so now that the pinion preload is set with our solid spacer, we can toss in our oil retainer, slinger plate, and our Marlin Crawler Eco Seal to finish off the pinion end. Now it did take about 215, 220 foot-pounds to get that preload all the way to 10 to 12 inch foot-pounds. And that's totally fine, and that was the smallest shim that I had. So if it wouldn't have got there, I would have had to wait or buy a different shim or actually turn down that spacer a couple thousandths of an inch to be able to properly shim this thing. But when you install a standard crush sleeve anyway, you're like incrementing by 10 pounds until you get the right preload out of that. So it's okay to, you know, run a little bit more torque on this than we were going to, and the factory spec is 181 foot-pounds. These Marlin Eco Seals are the best on the market. Now, I'm not sponsored by them or anything, but I've never had a leak using one of these. They drive to perfect depth because of that flange. They have a bead of RTV around the sealing area, and the inner spring is just way better than OEM. I wanted a new pinion flange, so I picked this one up from Yukon, but what I found was that the dust shield was too shallow compared to the one that comes on the pinion flange from the 80, which had a lot more depth. So as you can see, I had to press the dust shield off the old pinion flange and then press it onto the new one to make it work. And the old flange also had a groove, which may have led to a leak. Well, this video is taking forever to finish because I keep running into issues with parts. When I was finishing up that solid spacer install, I noticed an issue with the solid spacer and had to order a new one. And it was taking forever to get here, so it's a week later since that last clip. And in the meantime, I've been working on interior framing in the shop. And now that the new spacer showed up, I can show you what was going on, and it's a really, really frustrating situation. So let me just show you what happened. All right, so as you guys can see, this solid spacer from Nitro is supposed to be 2.090. And when I measured this thing, it came out to be 2.104. So it's about 14 thousandths, and I actually started to sand it down. So it's 15 thousandths larger than it was supposed to be, which explains why a 10 thousandth shim was too tight and a 12 thousandths shim was too loose because we're already 15 thousandths out of spec compared to what it is supposed to be. Another issue is that if you take a look at this thing, how loosely it fits on this old pinion. I have the new pinion already installed, so I can't really show you on the new pinion, but this would sit about right here, and it fits that loose on the pinion. So then when you translate that to where it sits on the bearing, look how close it is to the edge of the bearing there. And since it has the ability to move, it could technically push up against the outside of that bearing and ride on it, which, as you can see, where did that go? Right here. See that scoring on the side of that? That's because it's riding on the inside of that bearing. So as you're installing this, you kind of have to spin the pinion flange as you're tightening it down to make sure that it doesn't get hard or tough to turn in any one spot, which would indicate that this is touching the inside of that bearing. So super, super frustrating situation. Not to mention the new one that I ordered from Marlin, which is already installed, and I have everything set in here. I thought I'd be getting a Marlin crawler spacer. Instead, I just got another Nitro spacer. And the Nitro spacer that I got from Marlin was also 15 thousandths too big. So what I ended up doing was I just put some sandpaper down on my flat metal workbench here and just sanded 15 thousandths out of it to get it down to 2.090 where it's supposed to be. And then I was actually able to use the correct shims to get this thing to the right preload. And so now we can finally finish, this setup, which I cannot wait to get done. With everything assembled, the last step of the gear setup is to get some preload on these carrier bearings. I mark where the adjuster rings currently are, and then I turn them as far as I physically can. I was able to move both sides in 2 notches, which should really strengthen everything up, and now we can move on to the air locker setup. All right, well, finally done with this thing. Just gotta do a pressure test real quick. So this is a tester I made. I have it in the video from the front differential, a lot more in depth on how I made that. It's very easy, but it's way cheaper than the one that they sell. I think this thing is like over $100, and this was like 20 bucks. So I'm gonna pump 90 PSI into this, make sure it holds for 15 minutes, and we'll be done. Well, it's been 15 minutes. We got no leaks, so this thing is finally done. And I won't lie to you guys. For a while there, I thought I would never finish this video with all the things that were going wrong, with the solid spacer not fitting, ordering the new one and having the exact same issue, the bearing, the race, all the stuff that I couldn't possibly be ready for. And I just thought we'd never get this video finished, but here we are. It's finally done, and as far as I'm concerned, this Land Cruiser is now triple locked with way better lockers than what it would have came with, even though we had to go through all the crap to get these ARBs set up. So if you guys like this video, give it a thumbs up, subscribe to the channel if you're not already, and I'll catch you guys in the next one. Later.